Hello, my name is Riley Barmore, and this is my knowledge construction slideshow. So I decided to uh, choose my younger brother, my youngest brother actually, William. He is 13 years old. Make sure I'm thinking about that right. Yep, he is 13 years old. His birthday is in September. Um, So I decided that I wanted to teach him how to solve a Rubik's Cube. Um, and these are the prototypes that I decided to put into this slide because these are the different steps that you would take in order to, once you get to solving a Rubik's Cube. The final product, of course, being this uh, final solved Rubik's Cube. Um, because there's different steps that you're looking for in order to solve a Rubik's Cube. So, such as in step one, you have the white cross where the middles are also going to line up. And then on the second step, you're getting the corners in the right spot. And then the third step, you're getting those middles. And the fourth step, you're getting this yellow L. And then the fifth step, you make a yellow cross. And then the sixth step, you align the corners to be in the right spot. And then you finally just do the final step will get you to where you have a solved Rubik's Cube. So some overgeneralizations and undergeneralizations that I thought of. Overgeneralization comes from whenever you say a comment that you would think applies to more than what it actually applies to. Undergeneralization is whenever you say a comment that uh, it actually should apply to more than what you're saying. So an example, there's only one way to solve a Rubik's Cube. That is an undergeneralization because there's several ways to solve a Rubik's Cube. That's why that's why there's people that have solved Rubik's cubes in under 10 seconds because there's different ways to solve them that are faster and more efficient than the way that I'm going to be teaching my brother. It's just that for teaching my brother, it's the beginner method, which will uh, make it to where he goes through the same steps every single time. And over generalization, if you can solve a 3 by 3, you can solve any cube. If you look at this picture, there's a lot of different kinds of cubes. I put that in quotes because not all of them are cubes. Um, you use a lot of the same methods in solving a lot of different kinds of cubes, but it does not necessarily, just because you can solve a stereotypical or regular 3 by 3 by 3 does not necessarily mean you can solve any Rubik's Cube. And then an overgeneralization is that it's too hard. Solving a Rubik's Cube is simple once you find the steps to solve them, to solve each layer. It Once you break it down, it makes it a lot simpler. It's not too hard for anyone to learn. Defining characteristics or features. These are things that are all you will always find in a Rubik's Cube. Um, so specifically for a cube, unlike what we see in this, not all of these are cubes, right? But in a cube, you will always see 6 faces, where each face has its own individual color whenever it's completely solved. You do use algorithms to solve any cube. It doesn't matter what cube or what algorithm you're using, it is an algorithm that you will use. Some things that you'll find in some cases, uh, uh, that you won't find in all cases are correlational characteristics. So, for instance, not all Rubik's Cubes have the same colors. Not all of them have the same color scheme with red, orange, blue, green, white, and yellow. Some of them have pink and purple and just other various colors. And you don't have to have all of the same colors. It's just knowing what the correlation is between each color that will help you to know how to solve it. And I did say, so I put 6 faces and 6 sides on both the defining and correlational characteristics. And that's because, as I showed you before, not everything always has 6 sides. Um, and I mentioned how there are 7 steps to solving a Rubik's Cube. That is, again, the beginner method. There are other methods where you can take uh, shorter steps or not as many steps to solve. Stickers on each piece. There are stickerless cubes that are better, in my opinion, because it doesn't fall apart as easy and you can keep the colors lasting longer. And then there's stickerless, which obviously there are more cubes that have stickers on them that or it's more known for a Rubik's Cube to have stickers on each side to represent their color. So some logic system, some things to think about when dealing with a cube. Each face of the cube turns individually. You can know that just by playing around with it. You don't have to know how to solve it. You just know that there's moving pieces individually. And you have to turn a specific face to get the piece to face a certain way. So if I want a piece, a color to be facing towards me, I have to turn the face that it's on a certain way in order for that to happen. So some mnemonic devices. There are different ways that I remember um, how to solve the Rubik's Cube, or I remember each step. There's models that I'll look at. Of course, there are pictures that will show which way you need to turn a piece in order to get a desired result. Um, an ode or a rhyme. I think of different stories, I would say, whenever I'm solving a Rubik's Cube, and that's what I'll use when teaching my brother. I'll teach him in the beginner method all of the things that I think about with the stories. Um, and there's images that I think of and connections that I make of whenever this happens, whenever I do this, this happens. And of course, repetition helps a lot that I will use with my brother. Um, so the zone of proximal development. There's things that there's an advanced method to solving the Rubik's Cube that even though it's more efficient, it's harder to remember and harder to memorize. Um, for instance, F2L. F2L stands for first 2 layers. So after that first step of solving the white cross, you automatically go to solving for the corner and middle piece in the second layer at the same time. And that's more efficient and faster, but it's, again, harder to memorize from the beginning. Solving the white cross, that's important, and that's what I would say is easy enough for my brother to know to do, um, but not too easy to where he gets bored. Again, PLL is an advanced method where it's part of the last process of solving it, and that's just too hard. It's something that I'm still working on myself. Solving the edges. That's something that should be very easy. Just from what I would say. Solving the yellow cross. That's easy enough and something that is important. Um, So Eric Erickson's theory of psychosocial development. Excuse me. So William is 13 years old. He will fit into the identity versus confusion development. So something that I predict that he will try and do is he will try and turn his pieces on his Rubik's Cube the exact same way that I'm turning on mine. It'll be difficult because it will be through Zoom and it's not as easy. Um, but it'll be important for him to figure out how each of the pieces turn. Um, I will do my best to be able to set up my Rubik's Cube to look like his so that way he won't have that barrier to overcome of not turning the exact same pieces or not trying to turn it the exact same way uh, due to it being different. So, moral dilemma that I will show to him is, the possibility of doing his own process or doing his own algorithm to solve a piece. I want to see if he will follow the exact algorithm that I show him or do what he thinks is correct because there's technically no correct way to do it. Also, taking off stickers to solve the cube, taking part of the cube. That's not something that I'll present to him because that's just a lot of time and effort, not worth it. And that is my knowledge construction.